I feel that I have like 4 microphones, like maybe president is speaking, I don't know. So it's like a lot of them. Thank you so much for coming today. My name is Paul, and actually today I won't be talking about physics because I work in IT for the past 8 years. But today I will be talking about large language models. So it's like pretty maybe unusual topic for like nowadays, I guess. So we are going to talk about what is augmented analytics. I will tell you more about the client case that I did before in consultancy. We will build even the first MVP for client for augmented analytics. Then we will touch how large language models revolutionizing augmented analytics. Then it's like a secret topic, revealing the secret of red eye. I will tell you more. It's a little bit connected with artificial general intelligence. Then what will happen in 2073, prototyping with the Vertex AI, and we will see some demo as well. So very quickly about me, I'm a former physicist, technical leader with 9 years of experience in different industries and different domains. I started in system analytics, in entrepreneurship, data science consultancy, and deep learning. Also, I'm a road cyclist and a photographer. This is like 2 main hobbies. And so let's start. My talk is connected with augmented analytics. So what is actually augmented analytics? What is this? So I try to understand it through the Gartner glossary and actually Cambridge dictionary, because when I go to Gartner, augmented analytics was defined as, the use of something enabling technologies to augment how people explore and analyze data. And it's strange that something is defined through the same word. Then I needed to go to Cambridge dictionary to see that augment, it actually means to increase the size or value of something by adding something into it. So actually it's funny, I think it could have been applicable for different machine learning projects to what we do, so that we need to increase the value of something by adding something into it. So it's cool. But the 2 key properties is that we want to assist with data preparation, insight generation, and insight explanation. That's the first key part. And the second part, we want to increase the value of how people explore and analyze data. So this is 2 main key properties of what it means to say augment or augmented analytics. And I would add something else to this definition, because in 1990s, like we started with kind of coding-based platforms, and it required actually months to get some insights from this. Then in 2000s, it was visual-based platforms, like different business intelligence system, where you can use like your mouse as well to create some pivot tables, and it took like days and hours to get an insights to work with BI tools. But when we say augmented, I think we want to say that we want to get an immediate real-time insights. I think this is the key difference. And the third definition is in real time. So when to assist, to increase the value, of course, and do that in real time. So this is 3 key definitions, 3 key properties. So let's start quickly with client case. I actually used even like a Midjourney here to understand how it could be, because I didn't have a permission to use his real picture. So it was a small-sized company, like let's say 20 small industrial objects, pretty distributed. Each object was connected to the internet. We were collecting 100 data points per second. And actually, this entrepreneur spent a lot of time driving between different industrial sites and to deal with different problems, because he didn't know what actually was happening. And the first part was about building predictive maintenance system. I think it's a different topic. But the second part, he wanted to build a chatbot that will provide real-time insights. When he's driving, he can speak with it, ask some questions, how this objects, how it works, is everything okay? Could you please send me the latest, bar chart of something? And actually, this is what we built. And later now I can show you how we can create a small MVP for that purposes, and even use large language models to improve this. So let's go. If we think about how we can interact with the computer as a human beings, I think we have 3 main directions here. So we can chat with like text messages. We can use voice messages as well. I think maybe it can be even faster. And another stream that we will quickly touch, maybe the fastest way is to just think about something. But we will cover it a bit later. And in the same way, we want to receive this information, either to receive a text or voice or image. So that we can quickly analyze as well. By the way, does anybody know what this red circle means, which just popped up here? 1, 2, 3, 4, 5, 6, 7. Oh yeah, I mean, it's almost 20 people, I guess. No, this is really good because I thought that it is too complicated, but this is good. I will reveal the secret a bit later. Don't worry. So this is actually something that we want to build. Just take this into account. That's why it is between two humans here. So yeah. Oh, there is a question. Yeah, but I already asked that one. So okay. So the first stream is to receive a text from a human, create two submodules of our system, which is like text to code or code to text, and then send a text message. What we can do here, I think that the first very simple thing that we can do without using large language models, and what we did for this client, is just to create some kind of named entity recognition, SQL code interpreter, and rule-based natural language generation. So let's see how it works. It's very, very simple, how we can build very, very simple MVP here. Let's say I want to book a flight from Berlin to Mallorca for 2nd of next month around 2:30 p.m. Actually, that would be great. Yeah, I'm still thinking about this. So what we can do here, actually you can see that we have different named entities here, like flight, city from, city to, dates, and actually even word around, which is also a named entity because it's not strict. What we can do is we can convert this to SQL query, like select asterisk from flight and so on. So you can see it here. We need to convert this, extract these entities and put them into SQL query. Then we can execute this. If everything works, we receiving a table, and then we can actually generate a text message. Like, let's say, hi, my name is Hal. Actually, this is also one guess like about the red circle. So one tip about that name was Hal, but I will tell you about that. Thanks for a question. I found like flights for you from Berlin to Mallorca, flight number 1. So here's very simple MVP and how we can create these two submodules. So, but what's next? Actually, it looks very simple, but this is actually how it works in different commercial business intelligence systems that want to provide something like Ask Data feature. You can see here, you're typing what you would like to do. This is Tableau example. Actually just extracting the keywords, giving you some suggestions here, and creating visualizations. So actually, even though it's very simple, it works in different commercial BI systems. So the next thing that we can do, we can create a code to image block. And here we just need to add, let's say, some kind of Python code interpreter, and that's it. So then we just need one input text template and 3 different parameterizable code samples. It's like SQL code, Python code, and even output text template. But it can work. So we need to do a lot of customization, but it actually could work. So, and now it's very cool that from 2017, when Google released also Google Speech API, for now it's just very easy to plug in the Google Speech API to create speech-to-text and text-to-speech submodules. And this can add to our system some kind of sense that it performs like a human, because now it can understand our voice, it can generate a voice reply, and it's something like we're talking to human beings. So this is very cool and also very simple to do it right now. Then we come up with the following solutions. So we have named entity recognition, several parameterizable different query templates, Python code interpreter, let's say this rule-based natural language generation, and automatic speech recognition API, like Google Speech API, for example. So actually what's left here, I think we can add only one thing, it's user interface. And I will show you 2 main open source tools that are really suitable for that purposes. So the first one is we can use Telegram bot API. I don't know, by the way, I'm just curious how many people are using Telegram. Yeah, but actually it's quite good because I thought that maybe it's not very common in Germany, but it's good. So it means that it actually works, and a lot of people are using it. Thanks. So this is very cool because you can send anything like locations, files, images, stickers. Even you can roll a dice. So like, I don't know whether it's really useful, but you can do that. So, and the second option, which came just recently, because of the large language models, the Streamlit framework, which is based on Python, they released chat options. And you can see you just have 5 lines of code, and you can create a really like cool interface when you can create a chat and support your visualizations as well. So this is second option. And now, finally, we come up with something like this. So we have an input interface, we have a speech recognition, we have some kind of query validation module, then we're extracting these query parameters, do some matching with different dictionaries to understand whether it's flights or, I don't know, hotels or something like that. Extracting this data, executing these queries, and we do voicing and visualization of results. So actually, and it works. So it's very simple. With existing APIs, it's very easy to build such a system, actually. So now we're going to touch the main topic, how actually large language models revolutionizing augmented analytics. I wanted to give a very quick introduction to large language models, but I think Gerard did a great job already about that. I would just want to say that it's a family of deep learning architectures called transformers, and you need to remember 3 key parameters about that. So they are really large, they general purpose, and they are pre-trained on the very large data sets and could be fine-tuned with very small data sets for specific purposes. And there are different use cases like content generation, summarization, translation, chatbots, and so on. You can also see here, so I have 2 links in the presentation, but there are very cool small course from Google about generative AI, where you can learn, I think it's like you can spend 1 day learning about everything from here, and it's very, very quick and very cool. So also, if you want to dive deeper, there is a paper which is called Harnessing the Power of Large Language Models in Practice. And what is cool about this thing that actually the development of such models began even before 2023, even though it was recently very, very hyped, of course. But we have been developing these models for almost 5 or 6 years right now. It's all started from word-to-vec architectures and fast text from Facebook, and now we can see there's a very big tree, so you can actually explore a lot. There are a lot of different open source, cloud-based models. It's a huge zoo of different models. So, and now what we had before, so we had something like this, and now we can just replace almost everything with large language models. So this is kind of it. Because we have speech-to-text, we have large language model, which replaces our named entity recognition, different, parameterizable queries, SQL code interpreter, and just everything, because it just can do everything for us. We no longer need these parameterizable queries. So let's see where is this revolution, from where it comes from, actually. I think the main point here, what I want to mention is this shift from what we call, let's say, rule-based systems to something that is really contextual, which really has contextual and conversational reasoning. Because you can speak with a large language model, you can ask this model to generate directed from its text-to-text model, it's also text-to-code model, and I think we can introduce something like contextual and conversational reasoning already. So this is the key point why it's so cool right now. And so now we finally came to that point when we will reveal the secret of this red eye. And I hope that the video works. Let's try to, it's just 2-minute sample. I think it even less, like 60 seconds. Let's try and you will understand what it is.
I'm sorry, Dave. I'm afraid I can't do that. Well, I think you know how the problem is just as well as I do. What are you talking about? This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you are prepared for planning to disconnect me. And I'm afraid that's something I can't allow to happen.
But I'd love to get that idea, Hal.
Hey, although you took very thorough precautions to impart to test my privilege, I can see you at it smooth.
So it looks like this is something that we are trying to build here, actually. So, yeah, let's hope that our system won't decide to behave in that way specifically. But yeah, and now can you imagine that this film was released in 1968, so almost like 55 years ago, and now it's actually happening in a way. So now we know what I meant when I put this red circle between two humans there. So that's it. So let's go next. Oh no, we don't want to watch this again. Yeah, but this raises a very interesting question that, of course, will require another, lecture or a large meetup about that. Are we close to artificial general intelligence, which is called AGI? I think short answer is not yet. And if you're interested about this, to read about this more, you can check this out, this nice paper, which called "On the Danger of Stochastic Parrots. Can Large Language Models Be Too Big?" And actually, authors are saying that even though they can mimic the reasoning of the human beings, they're still like stochastic parrots that are just trying to mimic this, and they don't have a real reasoning. So that's it. But you can learn more here on this thing. So let's imagine what will happen in 2073. And I was just trying also to put here the third stream, because our ideas and our thoughts is still the fastest stream. We don't need even to write or send a voice message. We just need to think about it, and then I don't know, system can answer something to us. And I think the best guess, let's see, is it true or not, but the best guess would be that Elon Musk is working on Neuralink topics. At least you can see here that they are creating an implant that can be connected to your brain, then read your brain activity, and then you can even calibrate this to see that, for example, imagine pressing down the button, the blue button, and then they are reading your activity and trying to connect, also the train neural network to connect this brain activity to specific actions. Like you can control your cursor, you can do something. So that's interesting. So if you haven't heard about this, this is Neuralink project. So maybe, let's see, we will check this out in 2073. So yeah, 2073. So, and I also wanted to include here some ideas how we can use Vertex AI to build the augmented analytical system based on Vertex AI. And this was very simple because we also have, as we discussed, speech-to-text and text-to-speech some modules. And we also have a large language model in this framework. So we can just use this. Let's see, for example, if you don't know how to write a code to create a speech-to-text, or sorry, the first one is text-to-speech, you can just write a text here, generate a voice message, and then click a button, view code. And actually, that's it. Now you can use this code in your projects and copy-paste this. Just make sure that you have installed SDK for Python and it works. So this is very simple. The next one as well, it's very similar. So you can just recording your voice, then clicking the button, view code, and here's your code. You can just use it in your projects. So I would say this is very cool. And the same thing you can do with large language model. You can choose what you would like to do. For example, start a conversation and start a code chat, because we want to generate a code here to create some bar charts or some plots about our data. You were clicking this button. Now, of course, we need to do some prompt engineering to adjust the hyperparameters of the model. But then, again, view code, and actually it's as simple as that. So you just creating a chat model, sending a request here and receiving a response. On Python, I think it looks very, very, very simple. For my specific purposes, I decided to do a small demonstration. I took like a dummy data set from Kaggle and reduced this data set to only 2 tables. The first one is IMDb title basics. So this is a data set about movie ratings and different title ratings. And the second table is IMDb title ratings as well. So, and I engineered a prompt here, like given the following database structure consisting of 2 files with the following description, you can see it's like file number 1, 9 columns, file number 2, 3 columns. Please assist user with different visualization requests. Please use Python coding language, pandas, matplotlib for code generation. Please make sure to pre-process the data in the columns to numeric data types and so on. We even try to use error caching because I didn't know maybe there are some errors in the data or some broken, let's say, variables. And this is actually a prompt that I really used. And let's try to check the first demo that I created. So I just created a Telegram bot and I used these 3 APIs to build this system. So let's see, I think it should work.
Hello, I would like to understand the relationship between average movie rating and release year.
Sure, I can help you with that. Here's the code to generate a scatter plot of the average movie rating and release year. This plot shows that the average movie rating has generally increased over time. There is also a slight trend for movies released in more recent years to have a higher average rating.
Not yet, not yet.
Okay, cool. I think this is a little bit noisy. Could you please change this to the line plot and add some averaging, please?
Sure. Here's the code to generate a line plot of the average movie rating and release year with some averaging. This plot shows that the average movie rating has generally increased over time. There is also a slight trend for movies released in more recent years to have higher average ratings.
Wow, thank you. This looks nice.
You're welcome.
One more thing. Could you please add the plot title?
Sure. Here's the code to add a plot title. This plot shows that the average movie rating has generally increased over time. There is also a slight trend for movies released in more recent years to have higher average ratings.
Okay, thank you very much. Was it difficult for you?
You're welcome. No, it was not difficult for me.
Cool, thank you. And the last ask from my side, I would like to change the line color. Could you please change it to yellow?
Sure. Here's the code to change the line color to yellow. This plot shows that the average time. There is also a slight trend for movies released in more recent years to have higher average ratings.
Thank you very much for today.
You're welcome.
Yeah, so but you can see it actually works. Yeah. Even though maybe I guess with the BI system we can create this very fast, so this is a very simple plot. But still, you can speak to with the system. You can ask different questions, and actually, I think it works. I have also the second demo. Just let's check whether we fulfill these key properties. But I think that answer is yes. So the first one is we assisting with data preparation. We increasing the value, how people explore and analyze data. I hope we can say that we increase the value. I don't know, do you agree or not? But I hope that we increase the value. And we do it in almost in real time. So I think we fulfilled all the requirements here. So it's good. And I have just one final demo that I try to create something a bit more complicated, because before I think the large language model didn't join the tables. And here I wanted to ask her to do something a little bit more complicated and ask even to imagine what we can do with this data.
Hello, how are you doing today? Do you have any ideas which charts I can build with my data?
Sure. Here are a few ideas for switch charts you can build with your data. Asterisk, a bar chart showing the distribution of average ratings for movies and TV shows. Asterisk, a line chart showing the average rating for movies over time. Asterisk, a scatter plot showing the relationship between average rating and number of votes for movies. Asterisk, a pie chart showing the distribution of genres for movies. Asterisk, a box plot showing the distribution of runtimes for movies. These are just a few ideas, and there are many other possibilities. You can also combine different chart types to create more complex visualizations.
Okay, then, could you please create a bar chart showing average ratings for different title types?
Sure. Here's the code to generate a bar chart showing average ratings for different title types. This code will generate a bar chart that shows the average rating for each title type. The title types are asterisk movie, asterisk short, asterisk TV series, asterisk TV episode, asterisk video. The average rating is the weighted average of all the individual user ratings for each title.
Okay, there are a lot of different title types here. Could you please spot only top 5?
Sure. Here's the code to generate a bar chart showing the average ratings for the top 5 title types. This code will generate a bar chart that shows the average rating for the top 5 title types. The title types are asterisk movie, asterisk TV series, asterisk TV episode, asterisk short, asterisk video.
Okay, thank you. And the last request, my favorite, related to colors. Please change the bar chart color to something that is associated with Barbie.
Sure. I'm going to change the color of the bar chart to something that is associated with Barbie. This code will generate a bar chart that shows the average rating for the top 5 title types. The title types are asterisk movie, asterisk TV series, asterisk TV episode, asterisk short, asterisk video. The bar chart will be pink, which is a color that is often associated with Barbie.
Thank you. I hope the audience will like it at my talk today.
I'm sure the audience will like your talk today.
So that was it. Thank you so much for seeing this case with me of augmented analytics. If you want to connect on LinkedIn, of course, feel free to write me a message. I will be happy to discuss a bit more on everything, large language topics, physics, or augmented analytics, whatnot. So thank you so much for listening to me today.